Hi folks, Ram55 here, and I'm back with my second Kerbal Space Program NASA mission. Tonight we launched the Vanguard 1 satellite. So after a couple unsuccessful attempts, Vanguard 1 was finally launched into orbit on St. Patrick's Day, 17 March 1958, and it was the first solar-powered satellite and continued to send signals back to Earth until 1964. And it remains the oldest man-made satellite still in orbit today. Pretty impressive. Overall, there were 11 attempts to launch Vanguard satellites, but only 3 of these were successful. However, all 3 of them still remain in orbit. Now, interestingly, the upper stages of the rocket used to launch Vanguard 1 is also still in orbit. So here's the rocket we're going to be launching today. Well, not really. This is what we're going to be launching today. Let's go back to that other one. Now, the Vanguard mission was developed by the Department of the Navy Laboratory, and it had several goals. Number 1, it was to test the 3-stage Vanguard launch vehicle. Number 2, it was to measure the effects of the environment on satellites in orbit. And 3rd, it was to take physical measurements of the Earth. Now, these measurements showed that the Earth is slightly pear-shaped with the stem situated at the North Pole. It also determined that the effects of solar wind and the drag of the Earth's atmosphere are greater than originally estimated. In fact, the Vanguard 1 satellite was originally thought to be able to remain in orbit for about 2,000 years, but due to solar radiation pressure, or solar wind, and atmospheric drag, estimates are now predicting a life of only 240 years. Only 240 years. Before its orbit decays and it burns up into the atmosphere. Now, Vanguard itself was a small aluminum sphere about 6.4 inches in diameter, weighed about 3 pounds, and had 6 antennae protruding from its surface. Because of its small shape, Soviet Premier Nikita Khrushchev described it as the grapefruit satellite. Now, once again, in Kerbal Space Program, we don't have the parts to make a reasonable recreation of the rocket and the satellite. But with a little imagination, we can at least capture the spirit of the vehicle. So here's my effort. After a lot of experimenting with different sized fuel tanks, I settled on this design. It's a 3-stage rocket with the satellites perched on top. The first stage is made out of a FLT 800 fuel tank, as well as 2 FLT 100 fuel tanks, and it uses an LV-T45 rocket motor for power. It has the usual stabilizer pins at the base for stability and steering, and this rocket motor is also gimbaled, so that will also help in steering. Now, the second stage has 1 FL-100 fuel tank and an LV-909 liquid fuel engine for power. It also has that FL-A10 adapter at the top to transition to the 3rd stage. And the 3rd stage consists of 2 Oscar B fuel tanks. It has the LV-1 liquid fuel engine for power. Get a better look up there. There we go. It has 2 Oxstat solar panels to supply power to the Z100 batteries. It also has the small incline reaction wheel to give it more maneuverability out in space, and the Octo-2 for control of the 2nd stage after releasing the satellite. Now, the satellite is simply the Sputnik Mark 1. It also has 6 symmetrically placed commutron antennae. I had to use the Sputnik simply because there isn't a control pod small enough to fit the purpose. Besides, it's round just like the original. Besides, when you don't have a Kerbal standing next to it, or a rocket next to it for scale, you have no idea how big it really is once it's out in space. Now, the actual Vanguard rocket is long and thin, and I tried to make the 2nd stage completely out of Oscar B fuel tanks, but unfortunately there isn't a satisfactory motor to slap on the bottom to provide adequate thrust. I ended up settling for a fatter rocket that gives enough thrust but not so much endurance because I want to make sure that the stages fall back into the atmosphere and don't hang out in orbit. Now, the original rocket was launched from Cape Canaveral at 6:15 a.m. It went into a 660 by 3,840 kilometer orbit with 34 degrees of inclination. Now, making that 70% adjustment that I talked about in my last video for Kerbin's atmosphere, that converts to a 462 by 2,699 kilometer orbit. Now, you may ask, where did I get that 70% figure? Well, that's based on what's called the Kármán line. And the Kármán line is generally recognized as an altitude of 100 kilometers that establishes the boundary between the atmosphere and space. Now, Theodor von Kármán calculated the atmosphere is too thin to support aeronautical flight at this altitude because a vehicle would have to be going so fast, it would be traveling faster than the orbital velocity to produce enough lift to support its own weight. So it really wouldn't be flying, it would be actually leaving Earth orbit. Now, because of the way the game models Kerbin being about 11% the size of Earth, but its atmosphere being 70% that of Earth, the orbits look a little exaggerated. Not quite realistic looking, I think, as far as relative distances away from Kerbin as they would be from Earth, but I think that's just the way it is. And I'm going to stick with my calculations of 70% unless somebody can come up with a better explanation. Okay, so here's our Vanguard rocket sitting on the pad with the Vanguard satellite perched up on top. We are ready to go. Now, once again, I'm going to be rotating the vehicle after liftoff to about 34 degrees to give me the correct inclination once we get out into orbit. And I'm going to throttle back to keep my velocity below 200 meters per second. So once again, we want to turn SAS on. We want to give the rocket full throttle by hitting the Z key. And we are going to zoom out just a little bit so we can watch this thing. And then we are ready for go. We're going to rotate the vehicle about 32 degrees there, so that worked out well. Now I'm watching my velocity, which is now rising to about 120 meters per second. Rising up over the ocean. Don't know what that ocean's called. They ought to give it a name. So going through 10,000 now. We're going to accelerate and we're going to start to pull this thing over onto its side. Start to get some lateral velocity to put ourselves out in orbit. Again, using that V indicator on the nav ball to do my steering, and the flight path marker will eventually catch up. They will be aligned. About ready to stage here. There we go. Drop over stage. Sayonara. Now we're watching our apoapsis, and we want to stop it when we get around 462. I'll slow down as we get there because as we get higher up in the atmosphere, there's less resistance to our acceleration. start slowing down now as we go through about 390, 400, 430, looking for 462. So there we go. We've got our main burn. We're going to be coasting up to a altitude of 462,000 meters. Let's call up the map mode, and we'll add a maneuver node here, and then we will pull on the prograde vector until we get this apoapsis out to a 2,699 kilometer distance, and that will determine how long we have to burn to get out there. Going through 2,699. Good, that'll work. Now let's call up the nav ball, and you can see that that maneuver node will be reached in 8 minutes, and about 15 seconds from now the burn will be 26 seconds in total. And once again, we don't want to have that stage out in space. I think we'll probably run out of gas before we get there. Let's point toward that blue marker, which will line us up with the correct orientation with the rocket when we burn, to grow our orbit to that parameter that we have there in the yellow dashed lines on the map mode. And now let's go back and look at our vehicle. Now I'm going to accelerate time. Now I have an alarm clock that comes on 3 minutes prior to that burn, so it doesn't let me overshoot, but I'm still going to carefully accelerate so that we can get up to the point where we need to burn that second stage. And if everything works out right, we'll run out of fuel before that gets into orbit. And again, we want to split the time that we make our burn before and after the maneuver node, and it's a 26-second burn, so we want to start our burn 13 seconds before the maneuver node and theoretically finish our burn about 13 seconds afterwards. So here we go. Let's fire up that rocket. Hopefully we will run out of gas, and we did. And now we are going to use the third stage. While we're doing that, let's deploy those antennae. And now we're going to watch Flight Engineer panel up in the top left as we continue to accelerate and propel ourselves into orbit. The periapsis is still negative, meaning that we are not yet in orbit. The periapsis is inside the surface of the turbine. And now it's breaking out, and we will see that grow. And we will fly that out to a distance of 2,699,000 meters. Again, I'll slow down as we get out there. Don't overshoot the mark. Beautiful view as Kerbin beneath us. We're now at 1,000,000, about 200,000 kilometers. So we're getting very much more acceleration. So now we're going to 2,300,000, look, 2,699,000, 2,500,000. 2,600,000. 2,697,000. I would say that's close enough. But let's check our orbit, see how we're doing. You can see once again it doesn't line up perfectly with the yellow dashed line. It's a little bit offset, and I think that's just because it takes us longer with the smaller engines to get out to that distance. In the meantime, our spacecraft is shifted around. But regardless, we're in the proper orbit. Let's get rid of that maneuver node, and our periaps is at 461,000 meters, which is right where we want it, and our apoaps is 2,697 meters, right where we want it. So from this point on, we can get rid of those just to make it look a little bit cleaner. Let's go back out here and let's get ready to launch our satellite. Let's look at it from this perspective. So the satellite will be launching right at us. And there we go. We have just launched the Vanguard satellite into its orbit high above Kerbin, and we can see our third stage drifting away in the background. So again, this satellite was solar powered. It's still in orbit today, even though the batteries are long since dead, and it continued to provide information about the shape of Kerbin and information about the effects of solar wind and the atmosphere on orbits. But let's shift back to that third stage, and we're going to get ready to fly that thing back into the atmosphere. So let's go back to the map mode so we can that's not what I wanted to do. We were on the right thing to begin with. So switch to, there we go. Go to map mode. We will set up a maneuver node here. We want to pull on the retrograde so that we will get down into the atmosphere. Okay, let's try to land it on the day side. A bit more spectacular, I think. And now what I'm going to do is simply accelerate time to get that booster out to that maneuver node so that we can burn it retrograde, decrease our orbit, and come back into the atmosphere. Now out here is the orbit of our Explorer vehicle that we launched on the last video. So you can see this orbit is much bigger, much further away from Kerbin than that one. They're both inclined at about the same angle, but because they were launched at different times, they have the same inclination approximately from the equator of Kerbin, but they're on opposite sides of Kerbin as far as their apoaps and periaps. So we should be getting an alarm clock telling me that we're close to that point. Let's accelerate the last couple of minutes so we can get up there. Close that now. We are more or less already aligned with our retrograde vector. Let's go ahead and fire that rocket. Watch our periapsis down at the left edge of the screen there shrink slowly into the Kerbin terrain, which means that we will impact the ground. And there we have it. So let's stop our burn. Let's go back to the camera view, and we will now follow this vehicle as it falls back to Kerbin. We're going to accelerate time. Let's get rid of all this stuff so we can just enjoy the ride. There's Kerbal, the sun of this system. And this vehicle is rapidly falling. Hopefully we'll see it come down in the day side of Kerbin as it re-enters the atmosphere. Again, once we get down to 70,000 meters, the time acceleration will automatically go back to real time. And we'll still accelerate a little bit as we come down. And here comes the effects of re-entry. There are some mods out there that have, I think they're called deadly re-entry or something like that, where vehicles will actually destroy themselves if they come back too fast, they get too hot, parts will destroy, which I think is pretty cool, but I'm going to try to do as few mods as necessary as I play this game. That Mach effect as we come through the sound barrier. Some giant peaks out there in the background. I'll have to go visit those someday. Successfully deorbited our third stage. So let's go back to the tracking station. We can admire our two artificial man-made satellites in orbit around the planet Kerbin. We have Explorer and Vanguard successfully launched. And there it is. Vanguard out in space, relaying all that valuable information to those busy Kerbal scientists back in their little workshops back on the planet. And get to admire the beautiful view as it slowly orbits the planet. Let's have a look at Vanguard, or excuse me, Explorer, to see how it's doing. So here it is out in space. Also supplying valuable information back to the Kerbal scientists. Well, again, that's it. We have successfully launched the Vanguard satellite using the Vanguard rocket into orbit. and appreciate you watching. If you like this series, give it a thumbs up, subscribe if you'd like, give me some feedback. As always, I'm always trying to make my videos a little bit better, and I need your feedback to do that. So I'm trying to give you a little information, a little history along the way, not as much as on the first one, but hopefully we'll have some fun as we do this. Now my next mission will be Explorer 3. I don't think I'll make a video of that one. And then followed by Pioneer. Now that'll be a little bit different. Now the Pioneer series was simply a probe launched at the moon. It wasn't designed to impact the moon or orbit. It was simply meant to fly by, get some information back to the scientists back on Earth, and fly by the moon, and then went into an orbit around the sun. So I'm going to be doing that here in Kerbin's Kerbal Space Program for my next video. So stay tuned, be on the lookout for that. And again, thumbs up, subscribe, give me some feedback, and we'll see you guys later. Keep the pointy end forward.